right, guys, we're going to look at these to see how you did. So the first one, there's a couple different ways you can go about doing it. I'm going to simplify in the parentheses first, then deal with the exponent outside the parenthesis, and then your last step is always going to be multiplying the two parentheses. So in this first parenthesis, are we okay with, we would have x to the 5th in the numerator? Does that make sense? The -2 moves up? Okay. Looks like our z will stay in the numerator, and then what do we have in the denominator for y? Yes, y to the 3rd. And then all of that is to the -3rd. I'm going to go over here and do the same thing. X's, how many and where are they? X to the 7th in the denominator. Yep, we're going to combine those. What about y's?
Y squared on the top.
Yep. And then z? Okay. So all of that squared. So we're good to that step. Yes? Okay, one step at a time. Now I'm dealing with the negative exponent. What that's doing, you can certainly take the step to write it out as x to the -15, z to the -3rd, y to the -9. Or what do you know is going to happen with everything in this fraction because of the negative exponent? It's all going to flip, right? So my y to the 9th is now going to be in the numerator. X to the 15th, z cubed, denominator. Are you guys okay with that? Again, write it out if you're like, no, I need to see that negative and then I need to move it. Fine, I don't care. Write it out. This one, I didn't have a negative, so it's going to be y to the 4th, z to the 10th, x to the 14th. Okay, so x's, how many are left and where are they? 29 in the denominator, right? Okay. Numerator, what about the y's? 13, good. And your z? 7, also in the numerator. So y to the 13th, z to the 7th, all over x to the 29th. How'd we do on the first one? Okay. All right, if you were stuck, hopefully it makes sense now. If not, ask me. Happy to walk back through any part of that. Okay, the second one, obviously trickier with those coefficients up front. You can do a couple of things. I might rewrite it with the positive exponents just to make sure my brain's okay with what's happening. And this would be c to the 4th, 3b squared, and then all of that to the -2nd. We talked about it in the first problem. When you have that negative exponent, what do you know is going to happen with everything in the parentheses? It's all flipping, right? Everything in the numerator ends up in the denominator and vice versa. So then you just have to do the exponent. What is 2 squared?
4.
4. That is in your denominator. The a squared would be in the denominator and c to the 8th also in the denominator. And your numerator then, what is 3 squared? 9. And then I'd also have b to the 4th. Okay, what are we wanting? No, that's okay. You're squaring it all, and the negative exponent means it's all flipping. Portion. Oh, sure. Are you okay with where I had x to the 5th on that first parenthesis?
Yeah, I just need it. I multiplied first.
You multiplied the parentheses first?
No, I multiplied the negative.
So you would have had -9 and 4. So you would have had the -9 would move to the denominator.
Yeah.
I'm sorry, and 6. And so it would add up to 15 in your denominator.
Yeah, I think I multiplied wrong.
Oh, okay.
I think I did the right thing. I just mixed up my numbers.
That's okay. It happens. All right, guys, same in the second one. I'm going to rewrite it So there aren't any negative exponents inside the parenthesis, and then we'll deal with what's going on outside. So this is going to be 3. The a cubed would come up. I'm going to end up with b to the 5th up there. 4, and then c squared in the denominator.
Let's do it.
Yeah.
How come in the second question, the first bracket, what did a cubed get? I thought a was cubed.
It is. I lost my cube. Thanks. So this would be to the 6th. Yes? All right. This parenthesis then, guys, I'm squaring everything and I have a negative. What does the negative exponent do? Flips it all, right? Does it ever make it a negative out in front? No, it does not. 4 squared is 16. That goes in the numerator. The c becomes c to the 4th. 3 squared is 9. It will be a to the 6th, b to the 10th.
What is the 8 to the
6. Are you looking in the first parenthesis?
Yeah.
Yeah. Because 3 times 2 is 6. Wait. All right, you're multiplying fractions here, guys. You can reduce anything in the numerator with anything in the denominator. So what coefficient-wise is going to happen here? Don't just automatically take 9 times 16. Reduce first. What can I get rid of? 9s. Yeah, 9s are going to cancel. And what about how many times does 4 go into 16? 4. So the only coefficient you have left is a 4. Okay, then A's, how many and where are they? Yeah, 12 in the denominator. What about B's? Good. And C's? There you go. Close? Does it make sense now? Okay. Anybody questions on that? How many got it?
I set it up so perfectly.
Good. All right.
Let's go.
Okay, now our throwback questions. So for number 3, you have to factor. What does that numerator factor into?
X minus 9.
Good. What does the denominator factor into? Good. So what do you see right away? Whole. Okay. Where is it? And 11 over 8, lovely. Vertical asymptote. Good. Horizontal asymptote. Good. Let's see, x-intercept. 0, y-intercept. Good. We're probably going to need an extra point, but we'll wait just a second here. Okay, so I'll plot these 5, 2, 3, 4, 5, 11 eighths. That's more than 1, but less than 2, so somewhere in there. Vertical asymptote at -3. Horizontal at 2. X-intercept -1/2, 0. Y-intercept 0, 1/3. Okay, so we've got this side pretty well. We're okay with that part of it. Okay. Extra point, what are we going to plug in? -4. What do we get with -4? Good, so that's up here. Follow your asymptotes, and there's your graph. Are we remembering?
Yep.
Okay, yep. Gotta stay in there, guys. All right, then your last one, this is a number line problem. What are the 4 points on my number line? Good. Okay, something I noticed on your test, you guys would check 0, but you'd put it in the wrong part of your number line. Like you'd go, okay, I'm testing 0, and then you'd put it like in here between 1 and 4. Is that where 0 lives?
Yes.
No,
Yes.
it does not. Double check that, guys. Make sure you're not always testing necessarily the middle part of your number line. Found a new roommate somewhere? Yeah. Zero's in between -2 and 1. So 0 minus 1 cubed is negative. 0 plus 2 squared, positive. 0 minus 4 is negative, but you're squaring that, so that's going to also be positive. 0 plus 5, positive. So what is that section overall?
Negative.
Okay. Then it's down to multiplicity. The 1, even or odd multiplicity? Okay, so it's negative on one side. What will it be on the other side? Good. The 4 has even multiplicity. So what will it be on the other side of the 4? Also positive. Good. Going back the other way, the -2. What kind of multiplicity does that have? Even. So what will it be on the other side of that one? Negative. And then what about the other side of -5? Positive. Okay. So we want where this is less than or equal to 0. So the negative part. Now the or equal to, are we going to include the -5, -2, 1, and 4? No. Okay. What if the 4 had come from the numerator? Would I include it?
Yes.
Yeah. If the 4 was part of the numerator, you'd have this weird, like, one little dot on its own. It was not, so this one's not included. This is. So the way you write your answer, guys, don't write -5 to -2 and then -2 to 1. We just say parenthesis -5, 1, bracket. Okay? It's that entire section. If we were jumping over the -2, you'd have to tell me that, but we're not. It's just included in this.
Actually, I don't write number 2. But I set up
All right, guys, questions on your warm-up? Okay, notes time. I know that was a long warm-up, guys. Notes are probably shorter than your warm-up. Like an endurance warm-up.
You are very warm.
Yup, you're ready to roll. All right, guys, and we're just jumping in with examples, okay? We are solving. Okay, guys. Solving exponential equations. Eventually, we're going to get into where you use logs to solve the problems from the variables in the exponent, but not today. Today is all about the exponents and the bases. You need to make the bases match on the two sides of your equation. What base do you think I should use here? 2, yes. So 2 to what power is 4? Okay, and then I still have to the 3x out here. 2 to what power is 8? Okay, and then still to the 2x minus 1. All right, exponent rules here. 2 to the second to the 3x. What is that really saying? 2 to the what? 6x. Remember, power to a power, we multiply. That's why we have to review those exponent rules before we solve. The other one, what is it going to be? 2 to the what?
3.
3. Good. 6x minus 3. All right, Henry, you with me? Okay. Bases match, exponents are simplified. We're not like canceling out bases here or anything, but we are going to set the exponents equal to each other. The only way this equation could be true is if these exponents are equal. So we're going to say 6x equals 6x minus 3. And then you're just back to solving like an algebra 1 equation. So what do I get here? 0 equals negative 3. Does 0 equal negative 3? No. So this is a no solution. You will occasionally get a no solution. Now, guys, if it's x equals 0, that's fine. But if you get, 5 equals 2, something that's just not true, that's a no. All right, you guys try the next one. All right, guys, couple of ways to go about doing this one. 9 to the negative 2x minus 1. 81 to the 3 minus 2x. Check in with each other. Do you have the same answers?
You can't divide it by 2.
Do you want the basis to match? Now I'm cheering. Thank you so much. I have questions. Hold on.
Oh, that's what
That's it. That's it. And you can use a base of 3 or a base of 9.
You're already
I'm glad you're off crutches. All right, guys, let's go through it. Multiple ways to get there, either a base of 3 or a base of 9. I'm just going to use a base of 9, so I only have to change one side. 81 is 9 squared. So this is going to be 9 to the 6 minus 4x. There's only, yeah. He doesn't know the procedure yet. So 2x equals 7. Less reducing if you use the 9, but you should still get the same answer if you do the 3. Okay, so 7 halves is what it is. If you had 14 over 4, guys, just reduce. Questions on number 2? All right, let's try again. This one's a little trickier. All right, guys, try this one. Times 25. Again, multiple ways to go about doing this one. Yeah. Wait for whoever just left. Who did this? Adam.
What do you do with the? I have sort of. What page? Oh, you did fine. Yes, good.
And out of 5. Try again.
What did you do? Oh, maybe that. No, I'm not sure.
I don't know why. So like, it's so what you do plus 6 plus 6 plus 2 is 8. No, but I did 6 plus 6 times. Oh, really? Right.
Oh, you're right.
No.
So like, even I do all first,
I'll take 5.
and then you still have to multiply these. Oh.
Yes.
You were here. Good.
Sure. You know what? Not. It's not 5 to 6. It's negative 5.
What?
Is it like
We got the same shape. Like, if I have.
Oh, you had yes. Oh, wait.
Okay.
Wait.
Gotta use your exponent properties here. Yes.
Is there another way? Aha.
There's 2 ways to do this one. I'll show you both. All right, guys, let's look. Okay, so we can go base 5 with all of this. 125 is 5 cubed. 25 is 5 squared. 5 squared. Everybody was pretty good with that. We multiply here. Power to a power means multiply. Okay. 5 to the 6x plus 6 times 5 squared. When you have the same base and you're multiplying, what do you do with the exponents? You You add them. You do not take this times 2, guys. You add them. Gotta know those properties. So this is really 5 to the 6x plus 8. 5 squared. So 6x plus 8 equals 2. 6x equals -6. We get -1. Okay, let me show you the other way you could do this.
How did you get rid of the square?
I added it. So if I have like x cubed times x squared, what do I do with those exponents? No, you add them. So like in this step over here, I have the same base and I'm multiplying. So what do I do with the exponents? Yes. That and this are the same kind of problem.
Genius.
Okay, the other way you could do this, guys, start the same way. You really wouldn't even have to do this initially. You could divide both sides by the 5 squared or just divide by 25. So you now have 5 to the 6x plus 6 equals what on the other side? 5 to the 0, right? You have to recognize that 1 is 5 to the 0 because you need that same base. So 6x plus 6 equals 0, 6x equals -6, x is -1. As long as one of those methods makes sense to you, we're good. Okay? Yeah.
Could we just like divide by
25 initially. Yeah. Mm-hmm. Yep. All right.
Perfect. Yes.
Okay, 1/64 to the x plus 3. Equals 4 to the 2x minus 3. So make it not a fraction. That's your first step. What makes numbers fractions, guys? We've done so many. Okay. You know you signed up for pre-calc, right? You're going to do stuff like this. What base are you using, guys? 4? No. 4.
Wait, did I do that right? No, you're right. You're right.
I think I got it.
How we doing, guys? This one is a fraction.
Did I get it right? I was close though. I was close. Why is it so funny? I got a 12 into the 6.
So close, you double things.
Dude, playing things is a lot of fun.
My first you are sometimes I'll look up
Just made yes.
How long did you read
Writing it all down. Part of 5.
The same thing with Jackson.
Now it's negative 9 plus 3.
Some people, but I didn't mind this.
Wait, is it more like we're not sure?
Yeah, so most people want
But I also like that.
yeah. Yeah,
All right, guys. So this is a base of 4. It's 4 to the negative third. That gives you 1/64.
What?
Okay, what?
-4. I did everything with
That is correct. Okay, I'm going to jump right to the multiplying. Are we okay with me saying negative 3x minus 9 equals 2x minus 3? Are we fine with me just going to that? Okay. So I will get negative 5x equals 6. So x is negative 6/5. Starting with the wrong exponent will make it tricky. Adam, does it make sense?
Yeah.
Okay. Let's try another one. Last one, guys. Another fraction one. All right, guys, last one there. 1/27 to the 2x minus 1 equals 81 to the x minus 5.
I just see that from
All right, guys, what do we get for number 5? 23/10? Yeah? Okay, I'll go through it, but yes, that is correct. 3 to the negative third. 3 to the fourth. So negative 6x plus 3 equals 4x minus 20. So negative 10x equals negative 23. X is 23/10. All right, guys, any questions? Okay, I just want to give you the rest of the time to work on your delta math. Some of the bases that will pop up on those, some of them are fine, some of them are pretty big. I'm not going to give you crazy big numbers on any of your assessments, so try to muddle through the really large bases on there, okay? All right, guys, use your time.